mystery batons, and I need a volunteer. Is Elliot the only one who's going to volunteer? He volunteered for the last one when he hit the pennies. All right, Kira, come on.
No, that was Jackson.
Well, Kira, have you volunteered before?
No.
Good. Okay, just stand there and.
I volunteered before.
Okay, so just stand there for a moment. What I've got are these two batons, and they look identical. In fact, they're exactly the same length. If I check out their center of mass, center of mass of this one is in the middle. Center of mass of this one is in the middle. Well, let's see if they have a different weight. And their weight, if I can hook that, my Newton scale, it's about 12.5 newtons. You can hold on to that one. Don't do anything with it. And we're going to weigh this one, and it is 12.5 newtons. So would you agree that in the three ways I've described, length, center of mass, and weight, they are identical? Okay. So that means that I could take this one and I could throw it like a spear, as hard as I could, and it would go somewhere. And if I took this one and I threw it in exactly the same way, just as hard and at the same angle, it would go to the same place, right? Okay. So what I want you to do, Kira, is not throw it like a spear. I want you to rotate it, okay? So I want you to rotate it, big circles like that, as fast as you can.
Just like this?
Yeah, fast, really fast, big
This
circles.
is not fun.
Okay, good, that's good, okay. You haven't done this before, have you?
No, my arms are really sore from pole vaulting.
Let's try that one.
Oh god.
Is that one different?
Yeah.
Harder?
Yeah.
It looks
Well,
harder.
Not.
Really?
It's harder to do faster.
Try to do it fast.
It's harder to do faster.
It's harder to do it. Guess how much? Guess what? It's 4 times harder. That was 4 times harder to rotate. All right, thanks, you're done.
Okay.
Why do you suppose this one is so much harder to rotate than this one? I see one hand. Julianne?
Maybe because the more weight is on the ends.
The black one?
Yeah.
That's really good. Yeah, your intuition was right. So this is what I did to make this one. I made this back in 1996. How old were you? 1. Okay, so you were in diapers, and I was building this demonstration for you. So what I did is I took an 8-inch long piece of steel rebar, 1 inch in diameter, and I pounded it down. It was really snug, and so it sits right about there. 8-inch piece of steel. For this one, I took that same 8-inch piece of steel and I cut it in half. And I pounded it in only until it cleared the ends. So there's 2 4-inch pieces of steel like that. And so it turns out that when you want to accelerate something from here to there, force matters and mass matters. When you want to accelerate something rotationally, torque matters, mass matters, but there's one additional thing, the distribution of mass. The farther the mass is distributed from the point where it's rotating, the lazier it is, the more rotational inertia it has. And in fact, that's the bigger factor. That one's more of a factor than just the mass. If I doubled the mass of this, it would be twice as hard to rotate. When I take the mass and I spread it out twice as far, it's not twice as hard to rotate, it's 4 times as hard. Okay, so that's the mystery batons.